morning, everyone, and thank you for joining the Evolving Solutions Coffee Talk, Brewing Innovation and AI with IBM Z. Today, we are joined by Michael Downs, Evolving Solutions Chief Technology Officer, and Jim Fyffe, Senior Solutions Architect for IBM Z with Evolving Solutions. It's going to be a great call today, and I'm going to turn it over to Michael.
Awesome. Thank you so much, Kelly. Thank you, everybody, for joining us today. I'm really excited to have this conversation with Jim. I've had the pleasure of knowing Jim for quite a few years now, and he's a member of my team here in Evolving Solutions, and we've always had fantastic conversations around the mainframe platform and just technology and security more generally, so I'm super excited. I also just want to make sure that you know that we are, in fact, brewing up a great conversation here with mainframe and Evolving Solutions. Today, I'm drinking a little bit of something different. It's from a roaster in Appalachia, as they like to call it, in a place called in Virginia, a small town in Virginia that brews in a little roastery there and sends it out nationally. So nice French press. It'll probably keep me going through the whole conversation if Jim doesn't, and Jim probably will. So welcome, Jim. Thanks for joining me today.
Hey, it's good to be here. I've got a cup too, and I've got to show you it, okay? Long-lived, large systems. Those that know the platform know where this came from.
Yes.
And my cup of joe of choice is good old Dunkin' Donuts. So I did not go down the street to pick it up, but I have the ground, the beans. I've grind them fresh, and then brewed up a nice pot this morning. So I think between the two of us, it'll keep us lit up rather well.
We'll keep us going. I like it.
So
all right. The Z17 launch happened relatively recently, within the last month or so. What was the most exciting thing for you about this Z17 launch?
So when you look at that launch, I mean, there's a lot of content. Right?
Yeah.
And you could argue that it's Telum 2, it's the chip.
Yeah.
Right. But that's not necessarily my answer. All right.
Okay.
I mean, Telum 2, what is some of the stats? 35 billion trans per day. You can inference, right? Inferencing pays the bills.
Yep.
It makes a decision. And the net latency is a millisecond, right? That's very fast, right? What's some other thoughts? It's, the box we've got in the lab has got Telum 1. It's a great machine. Yep. Love it, right? Always looking for the next one, though, And it's based on the Telum 1 is 7 nanometer technology. Well, Big Blue drove it down to 5 nanometers on this. So further component integration. And when you do that, it drives up RAS. Fewer physical parts, improves RAS. But again, that's not my answer. I think what's most interesting about the Z17 announcement is IBM is focused on AI, whether it's generative AI, it's agentic AI. They get it, right? Our customers get it, right? And AI, Java likes a fast engine, like a fast clock and a lot of memory. What does AI like? They like a lot of power. They like energy. And somebody in the firm pays a light bill. So what Big Blue did is they looked at the hardware architecture, right? They studied the principle of operations. And they said, we have a component, it's the channel subsystem. It was the SAP, the system assist processor, been around forever, as long as there was a PSR and SC, whatever, And what they did is they took that bad boy and they basically put it on chip next to the Telum chip, right? It's on chip now. It's called the DPU, a data processing unit. Now, what that did, as opposed to when you initiate an IO operation on the big iron, historically, right, you got an application program in COBOL, does a read or a write to a file. It travels its way through the operating system, through a component node, the IO supervisor. He issues a start subchannel, throws it over the wall to the channel subsystem. And that was a remote call, a separate set of chips. Now it's on chip on the same core where that application's running.
So what does that do then? So having that sitting on the same chip, the same core, give me a real world situation where that makes a difference to a company or makes a difference to.
Well, why does it matter? It matters in the context of AI because it reduced the power consumption by 70% for the Z17. And the reason that's important is because we want to bring, generative and agentic AI capabilities to the platform. We want to do it within the same energy envelope the Z16 had. And so that's what I think is most interesting is the DPU. They want this Z16, tell them one, right?
Yeah.
Inferencing is important and we can improve upon that, but we're just not stopping there. The DPU is very interesting. There's some cool articles out there too. If you Google it, you'll find it. So that's my take on that.
All right. So you're saying that I should probably sell those shares of the data center building companies that I just bought because we're not going to need all of them. We're going to be able to squish it into a couple of Z boxes and.
Well, that's kind of another discussion. I mean, because we know we've got these Spire accelerator cards on the new Z17.
Okay. Well, so tell us a little bit more about what the Spire accelerator card does. How is that different than the on-chip accelerator?
Okay, so like an NVIDIA GPU, right? The massive GPU farms, as an example, there's a massive nest of those outside of a general purpose engine that hosts LLMs, right?
Sure.
And so and they're measured in something called TOPS, like trillions of operations per second, and it's a range from like 300 to 1500. It's like massive,
Okay.
And so what IBM did is said, look, well, we care about the environmental concerns within the data center. We care about electricity. Now, we can't go after a 1500 TOPS operation, but with the Spire card, 300 is a sweet spot.
Sure.
And so that's where it would compare, right? For those clients that have workloads that are subjective to some form of AI that don't really feel comfortable pushing it into the cloud, data privacy, data security concerns, you can host it on-prem. That's where the Z17 is going. Yeah. On-prem raised floor. It's quite interesting. So that's that's kind of a perspective and how the two differ, right? Fit. So
you just mentioned security. So let's transition to a little bit of a conversation about that. I want to come back to AI again a little bit later, but you mentioned folks are choosing to do AI inference sometimes on premise to keep their data on premise to give them maybe a better level of comfort that their data is living inside of their four walls. So that's one element of security. There's other elements of security, obviously, and as a CISSP, I know you talk about security pretty frequently. That's part of what you think about every conversation we have around this. What are some of the evolving things you're seeing happen on the platform around security? What's new? It's always been considered a reliable, secure platform. What are the sort of newer things that you're seeing that you're excited about?
Well, from an ISC squared perspective and the CISSP-ISSMP credentials that I hold, and trust me, I don't want to sit for those exams again. They're very difficult, right? I'll maintain my CPEs and thank you, we'll pay the dues together, I appreciate that. But, the attack footprint is extremely large now. It's just not behind the four walls in the data center. It's out on the cloud, right?
Right.
And then, and from and attacks themselves are highly sophisticated, using generative AI to morph, infectious payloads to hide, right?
Yeah.
So one of the areas that IBM's been focusing on is, what about the physical hardware nest itself, right? How do we protect that? As an example, when you boot an OS, how do you know it hasn't been changed?
Yeah.
Right. And so one of the items that Big Blue has brought to the table is the ability to digitally sign an operating system, right, securely. So at load, it hasn't been changed. And that's one example. So there's capabilities done at the hardware level. There's the Crypto Express, the 8S card that's been available since we bought the machine, right, in Z16, that maintains quantum safe algorithms. On the Z17, this is kind of cool. You've got the crypto cards. They're PCIe cards. You kind of plug them in, and that's a call from the processor. A little bit longer path length if you think about it, right? Yep. But for every engine that you have on the mainframe, so there's ZIPs, there's general purpose CPUs, there's IFLs, there's all those guys, and those that know the platform know what I'm talking about.
Yep.
There's something called a CPACF, and that's a high performance clear key encryption engine with high performance hashing and unique random number generation. And what they've done on the Z17 is they're working with a governing body to basically position TLS 1.3 to be
Okay.
resilient to what is basically harvest now, decrypt later
Okay.
when quantum comes up. It's a very interesting role.
So I'll explain it. You tell me where I'm wrong. So Harvest Now is an effort for organizations or nefarious organizations, threat actors, to grab data now that's been encrypted with older, lower quality encryption, so that in 5 years, 10 years, whenever quantum becomes available and the encryption is trivial for those computers to break, the quantum computer to break, they will be able to access that data. Even though it might be 10 or 5 or 10 years old at that point, it's still potentially very useful data because it could be social security numbers, bank account numbers, all those kinds of things like that. So what you're talking about with this quantum safe algorithm that's built into the Z now is you're actually able to keep the data from being able to be exploited in that way. Is that accurate?
Right. Yeah. Yeah, that's exactly right. I mean, there's basically, I mean, when you look at a platform, some data is not encrypted. All data should be encrypted. That's really, really hard to do that.
Yeah.
Then you could argue, Jam, wait a minute, man. When I stored that bad boy, those binary ones and zeros on the platter, right? Sucker's encrypted, you know?
Mhm.
Yeah, but once you drag it across the channel, guess what happens to it? It's in the clear again, you know? But there is, like DB2 can encrypt rows in a table, right? IMS can be encrypted. There's ways to encrypt. And yeah, you want to lead with, this is symmetric encryption by normally, because it's high performance. You can do asymmetric, but you don't lead with DES. Nobody leads with DES anymore. That's been deprecated back when I sat for the exam,
Sure.
back in '07,
Mhm.
but TDES they might think that's cool. AES, right, has different key strokes, 128, 256. The longer the key, the larger the key, the stronger the algorithm, right? You want to lead with those types of ciphers to say, look, if you have DLP, right? There's some form of data leakage off platform. You got a rogue actor that snuck in and
Yeah.
is command and control and FTP and stuff out to decrypt later. You want to protect. You want to select, but get on a platform with the right cryptographic primitives that can protect the data.
Right.
And the Z can
So-
do that,
So it's almost really taking that data security to the next level. It's not just protecting it now against existing threat actors who might have an access to it. It's actually protecting against threats that have yet to materialize. So, I mean, I think that's a place where IBM has always demonstrated leadership, especially around the Z platform and security, is just thinking to the next step, right?
Now, if I could, I mean, security, I'm somewhat passionate about it. And if I could
Yeah,
maybe
jump in.
expand on this a little bit, right? There's two phrases, cybersecurity and cyber resiliency. They're kind of buzzing around.
Yeah.
And as I look at Z, and I've kind of focused on ZOS, but Linux 2, S390X binaries are key. But as I look at ZOS tends to pay the bills out there.
Yeah.
Cybersecurity, as I look at, what does that mean? That means what technologies have you invested, stood up, and actively deployed on the platform that increase the work factor of a would-be attacker, make it very difficult to get in.
Yep.
And then there's something called cyber resiliency, right? It's interesting. It consists of some technology, IBM Z storage vault, which is IBM's DS8K, their flagship subsystem. And I'd probably pull in like a Roger Eklund or Philip Morris, some of those guys to know, yeah, this is old. Get to the current model numbers, right? But the point is, right, you've got an MVS image that's got channels to disk and you're right into that platter, right? And then within the storage subsystem, he can kind of look at those platters and go grab that data, full image copies, space efficient, that are in volumes that operating system can't see.
Yep.
This operating system over here can't see, and the command line interface to the box can't see it. They're really air-gapped images, right?
Yeah.
So cyber resiliency on Z17, Z16 as well, but there's something we call the cyber vault. And
Okay.
that plays into the concept of ransomware, which is another area the platform is very serious about on investing with the right tooling and the pricing structure
Yeah.
to make it cost effective for clients to even consider it. So that's a bit on security. That's kind of interesting,
Yeah, and it's really interesting how IBM continues to lead in that space and pull ahead in a lot of ways, I think, when it comes to the platform. There's already so much built in to be able to sort of add that extra layer as threats emerge is pretty impressive. So I want to go pivot back to AI for a minute, but before we go back to AI on the platform, I want to talk a little bit about some cool innovation around AI that's not exactly on the platform, but it's really interesting, which is the IBM Code Assistant for Z. Can you talk to me a little bit about
Sure.
what Code Assistant does and how that's transforming the Z environment?
Yeah, no, as a business partner, we do the studies, right?
Yeah,
And so that means I did time in Raleigh to learn it, right? And then you
yeah,
stick your nose in a book and you get a couple of gigs, which is kind of fun. But basically it's this. I work with clients that are actively developing in COBOL.
yeah.
They're actively developing in PL1.
Sure.
I know PL1. I did PLS back in the day, right? Which was cool. So PLS was the internal version of PL1. You could generate code and get down and do IO and weird assembler stuff in it. But that's what ZOS is written in. It's kind of exciting. But anyways, where we go with this, you've got COBOL, you've got PL1, right? You've got Java,
Yep.
right? But if we look at COBOL, right, and I've got clients, I live here in the Valley, that are actively developing in COBOL and hiring programmers out of college to service it. And so what are some of the challenges they have? Well, you've got legacy-based logic. How do you learn it?
Yeah,
Well, Watson Code Assistant for Z it's basically a pinwheel architecture, and what it will do is the very first phase of that pinwheel is called understand.
sure.
And so what you can do is you can ingest the COBOL source, all the copybooks, all the JCL that supports the jobs in production,
Mhm.
all the DDLs, if you're going after a database and how the tables it's going after, the rows accounts, you ingest that into a repository, a DB2 LUW repository using a product called ADDI.
Mhm.
That's the first phase of Code Assistant for Z. Once
Okay.
it's ingested, one of the things you can do is you can run an explain against it, right?
Okay.
You can perform and understand logic flows and isolate components you might want to expose as an API. And explain has different levels of explanation to help a new programmer learn, what is this thing doing?
So that works even if the program isn't documented well, right? You're actually using a large language model that's got all this history of COBOL and has sort of learned what all of these things mean. So I think this is amazing because you're essentially taking, ChatGPT, it's ChatGPT for COBOL, right? Here, explain this
That's
to me.
right. Yeah, the difference between ChatGPT and the Granite model that IBM uses, the
Right.
Granite model it's trained on over 160 languages, okay,
Okay.
internally. And so there's the understand phase, and there's the refactor.
Okay.
There's, and so you ingest it, you get logic flows, you get controlled flows, charts that depict how these different modules interact with each other, what tables are they touching, or what vSAM flat files, whatever the case may be. And then you can, like you said, new programmers, you can run an explain it gets in different levels and say, help me understand what this paragraph is doing, right?
Sure.
What are the dependencies? And then from there, you can say, I want to, now that I understand how an architecture looks, I want to focus on these modules. I want to do a refactor so I can basically refactor them in a format that will lend themselves to be called as an API.
Okay.
Optionally, we can optimize them, code optimization, and maybe transform it to Java if you want to. You don't have
Sure.
to. But
Well, and I
it's an
think,
interesting tool. And
well,
in
and
fact,
the
yeah,
thing
go
I
ahead.
think is most interesting about that is this ability to modernize the mainframe with minimal effort, right? Because I
Oh
think
yeah, no,
all the modern programming is done through CI/CD pipelines and microservices and so on. So there's a ton of applications out there that are calling APIs to get their work done. Mainframe has always been an amazing data platform, an amazing platform for high performance computing for particular workloads, right? Very secure platform, but I don't think people think of the mainframe as a participant in a modern application architecture. And
that
so this ability to quickly go from I've got this legacy code that I can't do anything with to here's an API that I can use HTML to call.
yeah,
That's pretty remarkable.
If I could expand a little bit
Yeah, please
further
do.
in the context of the Z17 announce, okay? So we've got Watson Code Assistant for Z. It's got COBOL support, it's got PL1 support, right? We understand the need for assembler. Big Blue does, right?
Yep.
And because it's out there, I see it, right? And then remember those Spire cards that I talked about earlier?
Yeah.
Right. So what, and I'm working on this with another client. It's really kind of cool, right? You know, when I've done these code assistant studies in the past, I get curated code from the shop,
Yep.
which basically says there's no IP in it, you know?
Right.
And then I basically got to push that off to the cloud, and then it's got to get fed, ingested into an LLM to basically say, interpret it, and
Yep.
you know, and either refactor it or transform it.
Yeah.
Some shops might not want their crown jewels to leave the raised floor.
Sure. Absolutely.
And so the Spire cards are going to allow you to have the LLMs on-prem, right?
Oh, awesome.
So it's an interesting space to watch. And, you know, it's not going to be till like the fourth quarter, which is a bummer, right? But even today, you know, and we have to buy a new machine to get them in ours. And I know when it comes up for the next,
Insane.
you know,
On the list,
we'll need a
Jim.
couple of
I'll get you.
But anyways, digital planning of the seed for the future, you know. But the point is, it's an on-prem capability. If you don't want your business logic to leave, it can be stood up on-prem using the Spire card technology.
Well, and I assume that that's not, I mean, so that's fantastic for being able to host that Granite large language model, IBM's foray into the large language model space that's really custom built towards supporting IT.
Yeah.
But those Spire cards allow you to host a variety of different LLMs, correct? It's not just the Granite model. You could potentially use that and go out to Hugging Face or any other
Sure.
repository and grab an LLM of choice.
Yeah,
So,
I mean, it's the use case piece that you might be hitting on a bit, right? And
yeah.
there's over 250 that are out there documented by IBM. It's interesting as I kind of look over the notes. There's predictive AI, there's large language models, and then there's something in the middle called multi-model AI architecture. And so there are certain fits. We've got to be mindful of, you know, how much horsepower the GPUs need, if you will, right?
Right.
The Spire cards, because we're in a very unique spot. 75 watts is what that card consumes in energy. We're cognizant of the light bill, the electric bill in the data center. Somebody pays it, right?
Yeah.
So we want to be able to do generative AI capability, bring it closer, bring it in the rack effectively.
Yeah.
And so for the right workloads, it'll be a very good fit. You know, and code assistance for Z is clearly one of them. And you know, one other thought, you know, there is Watson Code Assistant for C can be on-prem now.
Yeah.
And we're looking at this with another client on how we might perform the builds. I call it the lab, but when I'm in where the mainframe is, I look through that glass window. There's that other room where you guys do all the cool distributed build stuff.
Yeah.
And so we basically do, you know, LLMs or Watson Code Assistant, the LLM pieces of services. An interesting thing we're dabbling with, you know. So
pretty cool. So this AI capability, this LLM capability, we talked about Code Assist for Z and how it can accelerate that. Are there any other sort of business use cases that you could share where that AI capability is showing up? I know I've heard some people talk about fraud detection and things like that.
fraud's like a classic one, right? And you know what's really weird about fraud?
What's that?
When I was with Big Blue, you know, for 1980, I got hired. It was cool, you know. And then, you know, for a long time with the big banks, IBM's been chasing the fraud model, and it was tough. It was tough to get it deployed on the big iron. It was very, very expensive, right?
Yeah.
But when you look at what they did at the Z16 announcement, they introduced Telum, right? Telum 1, inferencing, 1 millisecond. And then they said, look, there's frameworks out there like, you know, like that are pervasive in developing a models. We can't go after all of them, but we can go after the key ones like Onyx and PyTorch and things like that, right?
Sure.
We can port those to the platform. And now between the Telum chip, They even had some vector capabilities, some SIMD stuff that was announced back on the 196 that I was like, what the heck's this for, you know? Because we were missing the underlying OS APIs to call it, you know? It's like, who wants to
Sure.
get out the principal ops and write a machine instruction to call this thing? But now
Uh-huh.
they got the API level there as part of the operating system. It's a perfect storm.
Yeah.
The seed work they did on the 196, and that was many moons ago, right? To the Z16, to the investment in open source technologies and frameworks that run natively on the platform, and then the hardware system. Now you couple that with Spire, going back to fraud, right?
Yep.
When you score a model, maybe you want to run it by an LLM and get another perspective on whether or not it's a fraudulent charge.
Oh, that's
Before the Z17 announcement in Spire, you couldn't do that. I'd be at Fry's trying to buy something, swipe on the card, sucker with timeout, and they'd all start looking at me. You're a bum. You don't pay your bills or something, you know. So it's like that's changing, you know.
I
So
figured with the too many transactions at Dunkin' Donuts. You know,
yeah,
if
that
Dunkin'
or
Donuts is too far apart, you probably couldn't have traveled that time in that
that's
period.
exactly right.
All right. So Jim, before we wrap up, I want to ask you another question here. There are probably some folks on the phone who are mainframe, steeped in the mainframe tradition and technology, who really know it super well. We've clearly touched some of the amazing things that are happening that make the platform relevant. What would you tell somebody inside of an organization who's a mainframe advocate? Because you're an IBM champion around mainframe. What would you tell somebody inside of an organization who's a mainframe champion who's trying to message to their leadership how the mainframe can play in a modern architecture, how it's part of a modern world?
No, that's a good question. I mean, you've heard the term legacy, right?
Yeah.
And it's a noun, you know. And so when you look at this thing, and so like it's like in my, you know, my little daughter Bethany, she's big now, but I know back in the day I used to do IT hangman with her, and it was MVS control blocks, and she thought I was just a geek, you know. Legacy. But you know what? The companies that have mainframe technology, you know, legacy is a synonym for it actually works,
Yep.
right? But to your point on modern architectures, right? Going back to COBOL,
Yep.
you can't do waterfall development on the big iron today.
Right.
You can't. You look at a lot of shops are stuck with legacy SCLMs,
Yep.
right? And that's not going to pass an audit, right?
Right.
You need dual control, separation of duties. So what IBM's done, which I think is very, very interesting, is first, I'm in front of a Mac, my iMac. I've got IDZ deployed. That's an Eclipse-based desktop, right?
Yep.
And I use that, and our developers use that. I use it to interact with an MVS system, ZOS, right? I like it, man. You know, it's kind of new, kind of cool looking, you know. But over, you know, on the right is another Mac, and there's another IDZ deployment there that dabbles with clients and application development, right?
Mm-hmm.
Now, when you look at IDZ, over on the left side of that of its screen, you can set views and you can connect to resources. One of the resources you connect to is a repository, a Git repository.
Yeah.
So what IBM has done is saying, look, we can't do waterfall. We got to do CI/CD, right?
Yep.
And so what IBM's developed is IDZ, VS Code. You might have heard of VS Code, right?
Yep.
All right. So IDZ is Big Blues. Either will work. You can deploy that on your desktop, and with the right instrumentation up on the big iron, which is like Application Delivery Foundation for Z, you can connect and you can interact. You can basically edit a COBOL source program at your desktop, submit it for a user build up on the host.
Yep.
That tooling is there. That's a CI/CD phrase, right? Once the build's complete, right, you can perform a pipeline build and push it over to an LL part to deploy the binaries into load lives, right? So we know we got IDZ on the desktop IBM Z. We got advanced started tests up on the host that we know how to install and configure because we've done it, right?
Yep.
And I've done it for clients, and it's really cool. We've got some really smart partners that know how to do the SCLM migration stuff. We partner well with them. And then here's another cool thing, right? You know, when you're doing the user builds, think about it. You've got the compile listings. You've got all this weird stuff, right? Which is part of like application development. It's got to be, they have to be logged.
Yeah.
You need a metadata repository to log all this stuff.
Right.
So that bad boy repository is DB2 on ZOS. Thank you, Jesus. That's what it is, right? Because
Nice.
the beauty of that is you can lock it down through RACF rules, right? So you need a repository. And then as you do pipeline builds, the beauty of this is once you get away from SCLM into CI/CD, you can pass those pesky mainframe audits because you can produce the evidence that proves it was separation of duties, that the person that made the change is not the same person that approved the change,
Yeah.
right?
Yeah.
That's key stuff. And that plays into modernization and digital transformation. You have to be agile. You have to do CI/CD on the platform. Or
Well,
if not, you're just missing it.
I love what you're talking about there because you sort of get a 2-for-1, right? I introduced this capability. I am now in a more modern application development environment that people coming out of school now, we just hired a 22-year-old who I don't think he can spell Z, but he's excited about it. So, but he knows cloud development super well. So we can come in and can do work on that environment like that because you've enabled it. At the same time, you've added a security capability and audit readiness capability that wasn't there before.
There's so much capability. It's so cool. We have a lot of this technology in our lab. You know, I love it, and I'll always brag about it. You know, so keep writing those checks. Thank you, Jamie. You know, but it's really neat.
All right. Well, I think we'll wrap it up there. To Jim's point, we've got this technology available. Anybody who's attending or listening today, we would absolutely love to get the opportunity to demo some of these things for you, share it with you. And as you can see up on the screen, if you've got questions, you can reach out to us at info@evolvingsol.com. Thank you for joining today. As Kelly mentioned earlier, we'll be sending out a Starbucks gift card. And thank you again for joining. Thank you, Jim. And let's
Thank you. It was fun.